Hi, this is another assignment walkthrough video. In this video, actually, I don't have a lot of Excel stuff to work through with you because a lot of techniques you need, I actually already demonstrated. So I think it's more important you understand the nature of those questions that's being asked in this particular assignment. So in this video, I'm just gonna quickly go over this problem itself. Okay, so here the first one is very classic problem called a Demir problem. Again, this is a very classic problem, so if you search internet, there will be solution all over the place. I don't want you to do that. I want you to sit down and think about this problem, okay, and then see if you can answer this problem using the framework of the binomial distribution. Solutions in internet may not be using the binomial distribution, so my specific requirement here is to examine this problem using the perspective of binomial distribution, which is not difficult at all. Okay, so there's a French nobleman and gambler Chevalier de Mere suspected that the chance of winning in the game 1 was higher than that of 2. So he's comparing two different games in terms of probability of winning. Okay, so here is the game 1, here is the game 2. So the game 1 says you will win if you get at least 1 6 in 4 rows of a single 6-sided die. So you throw a die for 4 times. Okay, the die is a 6-sided fair die. Okay, each side will have equal chance of showing up as the top. You throw that for 4 different times, 4 consecutive times, and then you will win if at least 1 6 will show up during that 4 throws. Okay, that is game number 1. The game number 2 says getting at least 1 double 6 in 24 throws of the 2 dices. So you're throwing 2 dices. You're throwing 2 different dices. Each one of them have 6-sided. Each one of them have 6 sides, just like the one you're throwing in the first game. But you throw it for 24 times. Okay, you will win if there's at least 1 double 6 showing up during that 24 throws. Okay, so the rule of the game here is very clear. And the first time you're throwing one dice, you're throwing for 4 times. Here you're throwing 2 dices and you throw it for 24 times. Okay, so you will win at least 1 6 comes up in first game. You will win at least 1 double 6 comes up in the second game. So through his experience, this gambler or the Chevalier de Mere has discovered that 1 actually have a slightly higher chance of winning, but he cannot quite establish why. Okay, so my requirement to you for this assignment is to calculate the probability of winning for each game, which sounds very intimidating, but it is not difficult at all if you examine using the framework of binomial probability distribution. Okay, so the first question is asking, please explain in detail why we can see the game 1 and game 2 as a binomial experiment. Again, this requires you to understand the concept, the definition, and the requirements of the binomial experiment. So if you forgot all of them, please go back to the slides. I think that is listed in the first page of the binomial experiment section. Okay, and what are the possible experiment outcomes for each throw of 6-sided die? So I'm asking possible experiment outcome for each throw. You just need to consider 1 throw. You don't have to consider all 4 throws, which is a requirement of game 4. Okay, just come up with all possible experiment outcomes when you throw 1 single 6-sided die. Okay, that's all you need to list here. But I do require you to list the outcomes using the set definition. Okay, so X here represents the random variable. All the possible answers should go in here. Okay, so I'm using a pronoun. I'm not giving you exact answer here, so you can put the first outcome all the way to last outcome. Just think about that. It's fairly easy. Okay. Number 3 is what is the probability of winning in the game? So again, the big framework here is the binomial distribution. So getting this is not that difficult as long as you can correctly identify N, P, and X that goes into the Excel formula. Okay, N, P, X. So the hint here goes, be careful on the wording of at least 1/6. Okay, so let me just jump to the Excel and show you something briefly. For example, I'm just gonna randomly list X and fx here, okay? And what I'm gonna do here is 0, 1, 2, 3, 4, and so forth. So the probability wise, I don't know, you can calculate the probability here, right? So I'm just gonna randomly give it 60, 30, 10, is it enough? 8, something like this. So if you're asking at least one, right? At least one, that means you need to add all these together, because that qualifies as at least one, right? So it also means you exclude probability of becoming 0. Okay, so again, for this part, you need to calculate based on the binomial binom this. Okay, so the first one is the number of success, which is x. Here we're throwing for I forgot, we're throwing 4 times of something, 4 times, and probability of success event. I think you can figure that out, right? In fact, you can figure it out when you list all the possible outcomes of each throw, okay? And then for this one, it's not going to be cumulative, it's going to be non-cumulative. Okay, so you just need to figure out what is this x here. Okay, x is this, right? And we're throwing for 4 different times, and what is the probability of showing the 6 on top? Okay, so you do the calculation, you complete that, that becomes your distribution. Once you got the distribution, you should be able to identify what is the probability of getting at least once. Okay, at least getting once. Okay, this area is the probability of getting at least once. Okay, anything that is greater than 1 and including 1. Okay, so think about that. It's a pretty logical explanation, isn't it? And what are the possible experimental outcome for each throw of 2 6-sided dice? So you also need to repeat things you have done in here. They kind of define the outcomes as the format of sets. So the purpose of question B and D is actually helping you to think, okay, helping you to think what is the chance of success in this particular game. Okay, so if you're clear with a chance of winning or chance of success through meditating question B and D, you should be able to use that to feed into your Excel to figure out what is the probability in here. Okay, so what is the probability of winning in the game? 2, again, go back and take a look at the condition, getting at least 1 double 6. So what is the chance of getting double 6 in each throw of your 2 6-sided dice? Okay, with that, I think you can finish this assignment easily. Again, do use Excel, okay? If you don't use Excel, it's going to be very difficult. So for the Excel, say N, P, X is all provided. So our N, let's say this is a 20. I'm talking about a completely different example here, okay? So this is just to showing you how to use the binomial this formula, just in case you forgot everything. And the probability of success, let's consider as a 30. Let's say we're interested in knowing what is 3 out of 20, with each time the chance of success is 30%. So, so we can say P of X, or you can say, I'm sorry, you can also say F of the X. Okay. It's going to be binom dist. 3 success event out of 20 trials. Each time the chance of success is 30, we're asking for non-cumulative. Okay, false. This is a chance. So again, I suspect that I will go through in greater detail during the class with regard to this particular Excel formula. If you don't remember, I recommend you to go back and take a look at the recording, okay? But this is the formula you need to calculate the binomial distribution. Next one is using the Mary Baker bakery data again. This is exactly the same data. I'm just wanna let you examine this data using a different perspective. So I ask you to calculate the average and the variance last time. I'm asking you to calculate that using the distribution instead of calculating using all the raw values, right? So I don't know if I still have that data somewhere here, right? Mary Bakery. So like here, I'm asking you to come up with a distribution instead of calculating average and the variance using this column B as is. So you need to construct a distribution. Okay, make sure this is not sum. Okay, some of you use the sum in your homework, which is not good. We're not looking for the sum, we're looking for the count. Okay, you also need to give a another relative frequency. This is actually the probability that is associated with each value of x here. Okay, so you should be able to calculate the expected value and the variance based on this table, not relying on this. Okay, so if you don't remember, I recommend you to go back and take a look at the lecture slide. And when you do the sum product, make sure you're not doing the sum product using column B and C. You need to do the sum product using column A and C. Okay, think about why. Okay, so I think that would, that will do for the entire homework 1 and 2. So it's not that difficult. You just need to think. Okay, so again, if you think you didn't have enough, if you think you don't have enough understanding on what we have learned in chapter 5, you should go back and review the lecture from beginning to the end. Chapter 5 is actually a very, very important bridging chapter. Okay, bridging chapter. So I cannot emphasize the importance of chapter 5 enough. So if you lose in chapter 5, you lose in, you cannot win in chapter 6, which is another bridging chapter to the chapters forthcoming. So okay, sit down and spend some time with chapter 5. If you need more time, just let me know. But I want you to do well on chapter 5. Okay? Thank you. See you next time.